What is the real problem with living on Mars? There have been several proposed human expeditions to Mars since the 20th century, both by public and private organizations. Most of the ideas about human machines that the national government space projects are considering will not be based on preconceived assumptions of colonial rule. Systems like those being temporarily run by NASA, Roscosmos, and the ESA are just meant to test platforms. While the goal is to build an existing base, this is not the primary goal at this time. Colonization necessitates the creation of long-term communities with the capacity to grow and support themselves. Robert Zubrin, a proponent of Mars colonization, served as the inspiration for the first two plans to establish communities on the planet, Mars Direct and Semi-Direct. But can we really live on Mars? And if not, what is the real problem with living on Mars? We must think about the following because the environment on Mars is unfriendly to human life. First, we should take precautions against cosmic rays. They are redirected to Earth's poles by the magnetic field there. Second, humans cannot survive in Mars' unique atmosphere. Third, the gravity on Mars is less, which will have an impact on how we move. Robotic rover missions discovered raw minerals that humans could utilize to build settlements without having to ship them from Earth. Mars is the ideal choice for colonization because it is the planet closest to Earth in our solar system. It was more like Earth today over 3 billion years ago, with flowing water that supported life and a magnetic field that shielded it from cosmic rays. Since then, the planet has lost both of these. But as I will demonstrate, there is still potential of terraforming Mars to make it habitable for humans. We might be able to begin the drawn-out process of returning some of the Earth-like environmental characteristics to the planet with the forthcoming planned trips. There are also ways to address the other problems, such as the threat of cosmic radiation. We are aware that the magnetosphere of the Earth shields us from harmful solar particles and cosmic rays by directing them to the poles and away from populated areas. The northern lights, Aurora Borealis, and the southern lights, Aurora Australis, are turned on by this. Because Earth has a metallic core, there is a magnetic field that is present. Mars formerly possessed a magnetic field. However, it was lost more than 3.7 billion years ago, presumably as a result of several asteroid collisions that destroyed the planet's internal magnetic core's dynamo action. This indicates that in order to shield humans from the cosmic rays that are assaulting the Earth, we would need to find another solution. Without protective gear, we would never be able to spend a day outside. Even if an atmosphere existed, we still couldn't venture outside unprotected like we can on Earth. Living on Mars will require doing all of our everyday activities inside of structures that shield us from cosmic radiation. It might even be necessary to construct underground housing. Oxygen is the next major unanswered query. 78% nitrogen and 21% oxygen make up the majority of the atmosphere on Earth, whereas 95% of the atmosphere on Mars is carbon dioxide. That's excellent news for plants, which use carbon dioxide to make oxygen through photosynthesis under the sun. However, oxygen is necessary for humans to breathe and provide their cells energy. The atmosphere on Mars differs significantly from the one on Earth. The most prevalent gas, carbon dioxide, can be transformed into oxygen, just as on Earth's surface plants do during photosynthesis. However, if we were to explore growing trees on Mars to change the atmosphere, it would take some time for it to become breathable. Even while we can breathe the air, it does not support human living due to the chemical composition. In addition, its atmosphere has a pressure so low that water boils there at body temperature. 14.69 psi is the atmospheric pressure on Earth at sea level. On average, Mars has a pressure of 0.087 psi. There is no way that humans could survive at this low pressure. One would need to pass through an airlock to enter and exit the living quarters in order to maintain the right atmosphere within. They would always be required to spend their time in a stressful setting. Another important element is gravity. Earth's millions of years of evolution have molded the human body. It is thus perfectly suited to a setting with a specific gravity and pressure value. On average, Mars has 38% less gravity than Earth. As a result, if you weighed 170 pounds on Earth, you would weigh 65 pounds there. Gravity is a result of the attraction between masses. An object's gravity will be stronger the more mass it has. All of the planets in our solar system are kept in orbit by the gravity of our Sun to prevent them from escaping into the galactic outer reaches. The moons of the planets are kept in orbit by the planet's gravitational pull. Mars's gravity is weaker since it is smaller than Earth. You may have seen videos of Buzz Aldrin and Neil Armstrong's lunar landing on July 20th, 1969. Every stride they took sent them hovering for a little while due to the reduced gravity, which made their footing peculiar. Since Mars is far larger than our moon, the experience would not be the same if one were to talk there. but the solid footing we've acquired since the first learning to walk as toddlers would still be considerably different from that. As you rise above the center of mass, the pull of gravity becomes weaker. On Mars, this gets more analytically challenging because the southern hemisphere has less mass than the northern hemisphere. When planning to transfer equipment and supplies to Mars for future colonization, it is crucial to take these gravity anomalies into account. Temperature is also a significant element that might make it difficult for us to survive on Mars. Mars is colder than Earth because it is far from the Sun, about 142 million miles, than Earth, which is closer, just 94.47 million miles. Mars' natural temperature is negative 85 degrees Fahrenheit, or negative 65 degrees Celsius. For humans, that is exceedingly chilly. Mars, however, is in the sweet spot when compared to Venus, which may reach temperatures of 867 degrees Fahrenheit or 464 degrees Celsius, and Neptune, which can reach temperatures of negative 328 degrees Fahrenheit, which is negative 200 degrees Celsius. It is also within a range that humanity can handle utilizing modern equipment in the living quarters. When Mars is colonized, we will have learned even more about the evolutionary history of the planet. We already know that it underwent at least one period of global cooling before arriving at the current state. The only question left to be answered is, can we make Mars habitable? Already, researchers are looking into how to change Mars by producing greenhouse gases that might raise the planet's atmospheric pressure. Terraforming is the name of this procedure. Though it is just a theory, it would make it possible for people to colonize Mars in a sustainable way by gradually making it more like Earth. But why go there in the first place? The fact that humans are more effective on Earth than robots and might therefore learn more about the planet is one of the justifications for sending people to Mars. The development of robotic probes throughout time, despite their limits, demonstrates that knowledge gained from them is advancing quickly. Robotic probes have the undeniable advantage of not requiring food or water, as well as operating under Earth's pressure conditions. Their electronic devices just require the barest of safeguards. One human mission would be predicted to cost the same as 40 robotic missions like Perseverance. Additionally, in accordance with the requirements of the Planetary Protection Act, which attempts to prevent contamination of the areas we travel to in the solar system, these probes can be sterilized once they leave Earth. With humans, this is impossible because we need to send a few members of our species to Mars. We simultaneously send billions of microorganisms from Earth. Even if their likelihood of surviving on Mars is quite slim, it is nevertheless a possibility and runs the risk of clouding the answer to the basic query driving our investigation of the planet. Might life have originated there in the beginning stages of its evolution? There will never be a life on Mars like one on Earth. There will always be a need for special housing and protective gear while going outside as a way to shield the human body from cosmic radiation. Maybe hidden communities are the answer. The astronauts wouldn't be coming back to the planet. This is referred to as a suicide mission by certain academics. I would view it as a relocation plan though, if they are successful in living out their lives there. Ultimately, a colony of humans is meant to live there permanently. Those who travel will have to come to terms with the notion that they will not have any family or friends save the mission's crew. It will be up to the team, which will comprise a surgeon and a doctor, to ensure survival in the event of disease. Despite all of these challenges, the anticipation of settling on the red planet motivates intelligent, hardworking individuals like Musk to develop solutions. Our chances of surviving after we arrive on Mars will increase the more issues we can presently identify with our possible life there.